Hi guys. So today is going to be another review concept where it's something you've seen kind of throughout every unit this year, but we're going to go ahead and kind of combine it all together here at the end. Just look at all the different functions. So for today, we're going to look at inverses. So before we look at specific functions, we're just going to look at the idea in general, just for any graph or table, so we remember how to find an inverse. What we do is we switch x and y. So let's take this first graph. So what we would do is take the coordinates on that point. So let's say they take the point -3, 0, flip the x and y. -3, 0 is going to become 0, -3 on the inverse. Looking at my next point, -2, 2, that's going to become 2, -2 on my inverse. -1, -1 is actually going to stay -1, -1. 0, 0 is still going to stay 0, 0. 1, -2 is going to become -2, 1. 2, 1 is going to become 1, 2. And then finally, 3, 0 becomes 0, 3. At this point then, we can draw our graph. And the next question is just asking whether or not that is a function. So in this case, no, the inverse is not a function because it does not pass that vertical line test. Remember that vertical line test, every x should match up with exactly one y. And in this case, some of your x's have multiple y values, so the inverse is not a function. Remember what we talked about, some specific vocab earlier this year was the term one-to-one. So if a function is one-to-one, then the inverse is a function. And the way we were able to determine that was using the horizontal line test. So if the original function fails the horizontal line test, its inverse will not be a function. All right, let's go ahead and look at a table. So to find the inverse, again, same idea. We're just going to switch x and y. So -4, 1, 5, 4, -3, 6, -2, 8, 0, 13, and 7, 15. We do not have to change any of our positives or negatives. We don't need to change any of the values. We're just switching the x and y's, and that gives you your new table. Again, looking at this one, each x does have exactly one y. None of those x's are repeating. So your inverse here is a function, which means the original function, well, I know this is really a relation because it's just a set of points, but let's say that these are some points on a function, all right? Then considering that if those were their points, then it would be one-to-one because, again, every x matches with exactly one y. All right, so let's look at some actual examples similar to what you saw this year. So we're going to find the inverse algebraically, and then we're going to graph them just to get some extra graphing practice in. So to find the inverse, again, we switch x and y. We're going to add 3. Square root both sides. And remember, when you take that square root, technically that could be plus or minus. But it's not going to be both in this case because look at your original function. Your original function had a restriction. X is greater than or equal to 4. The original function's domain is going to be the range of the inverse. So since this function is going to have a range of y is greater than or equal to 4, it's not going to be both the positive and negative square root. It's only going to be the positive square root. So my inverse here would be the square root of x plus 3 plus 4. All right, let's go ahead and graph the original, and then we'll graph the inverse. So I'll do the original over here. The original is a quadratic. Its vertex is at 4, -3. That point doesn't want to draw. There we go. No stretches or compressions or reflections, so it's going to follow that parent function pattern. So right 1 up 1, right 2 up 4, and then right 3 up 9. Now, typically, again, for that parabola, we would have that axis of symmetry, and we would kind of mirror image those points. But we're not going to do that in this one because, again, we're only graphing when x is greater than or equal to 4. All right, now let's go ahead and graph the inverse. So we're going to switch x and y on your graph if you want to do it that way, but I'm going to go ahead and just graph the square root function again for practice. -3, 4 is going to be kind of that starting point because it's shifted left 3 and up 4. No stretches or compression, so it's going to follow your parent function pattern. So right 1 up 1, right 4 up 2, and right 9 up 3. And there's your inverse. All right, so looking at another quadratic. Now remember, if it's not in vertex form, we got to do a little bit more algebra to be able to find it. The easiest thing to do is to use completing the square to rewrite it in vertex form. Now you can do this from the start, or you can do this after you've switched x and y. Either way, it doesn't matter, whatever you think is going to be easiest. I'm going to go ahead and do it at the start just to make the original function easier to graph. So I'm just going to rewrite this function into vertex form by completing the square. All right, to figure out the number that goes in the blank, take the b value, divide it by 2, and square it. And keep in mind, I'm not actually adding 4 to this equation. I'm adding 2 times 4. So I'm adding 8 to this equation. So in order to keep it balanced, if I add 8, I also need to subtract 8. Again, because it's on the same side. Now, if I put plus 8 over here, that also would work. But again, that would be on the other side of the equal sign. Subtracting it if it's on the same side is keeping that equation the same. So now at this point, I can rewrite this in vertex form. And now I have my original function. So let's go ahead and graph that. So your vertex is at 2, -5. This graph has been vertically stretched by a factor of 2. So typically that pattern would be this, but since we're stretching it vertically, we're multiplying those by 2. So right 1 up 2, right 2, and up 8. And again, we're only graphing when x is greater than or equal to 2. It has that restriction on it. All right, now let's find the inverse algebraically. So we'll add 5, divide by 2, square root both sides, and finally add 2. Again, it is going to be the positive square root because your original function had a domain of x is greater than or equal to 2, which means that your inverse would have a range of y is greater than or equal to 2. That range is going to be associated with the positive square root, not the negative square root. So let's go ahead and graph it. It's been shifted left 5 and up 2. Again, that parent function pattern for square root is going to change some because it has a horizontal stretch. So we're going to multiply those values by 2. And then the 18.3 is going to be off my graph. So there is my square root function. There's my inverse. All right, let's look at another one. So cubic, we'll go ahead and graph it. So that has been shifted up 2. So 0, 2. It's not a vertex for cubic functions. Remember, that's your point of inflection. So cubic functions, from that point, your pattern is right 1 up 1, right 2 up 8. Left 1 down 1, left 2 down 8. This graph has been compressed by a factor of 1/2. So from that point of inflection, right 1 up 1/2, right 2 up 4. And there's your graph. All right, so let's go ahead and solve for the inverse. Multiply by 2, cube root, and there's my inverse function. So that function is obviously shifted right 2. That's your point of inflection. So for cube root, remember, it's 1, 1, 8, 2, negative 1, negative 1, negative 8, negative 2. So from that point of inflection, that's how we're going to move. However, this does have a horizontal compression on it. So those x's are going to get multiplied by 1/2. So right 1/2 and up 1, right 4 up 2. And there's your inverse. All right, rational functions, a little bit different on the solving process. Let's go ahead and start by graphing the original. So in order to graph this, remember, we need to find the asymptotes. So I would need the vertical asymptote and the horizontal asymptote first. Vertical asymptote, we set the denominator equal to 0. Horizontal asymptote, we look at the degree of the top and the degree of the bottom. The degrees are the same, so I would divide those leading coefficients. So I get a horizontal asymptote of y equals 2. I also can find my intercepts. That'll give me a good clue of where to draw the branches of this graph. So let's say I want to do the x-intercept. The x-intercept, I set the top equal to 0. The reason I do that is because 0 divided by anything gives you 0, and the x-intercept is the 0 of the function, when the function equals 0. So my x-intercept would be negative 5 over 2. Your y-intercept, plug in 0 for x. So we can tell now, based off those 2 points, that I'm going to have a branch in that bottom left quadrant. I'm also going to have a branch in the top right for a couple reasons. One, because remember, those tangency rules or together rules, I can't go in the same direction at an asymptote unless that factor was squared. All right, now let's go ahead and solve algebraically for the inverse. So this would be x equals 2y plus 5 over y minus 4. So again, multiply both sides by y minus 4 or cross multiply, either way. And then the process here, very similar to what we did with logs. We want everything with a y on one side, everything without a y on the other side. The reason we do this is because now I can factor out that y. And then I can divide by what's with it. So I can get my inverse. All right, again, let's graph this. So for rationals, I guess the graphing is probably the hardest part here. So to actually graph this, vertical asymptote, set the bottom equal to 0. And I get x equals 2. Horizontal asymptote, look at the degree of the top, degree of the bottom. They're still the same degree. Divide those leading coefficients, which is going to be a negative 4 divided by negative 1. So that's going to be y equals 4. And you'll notice those are, again, switching x and y from the original function. So this is f of x, this is f inverse. We can go ahead and find our intercepts. X-intercept, we set the top equal to 0. So that's going to be negative 5/4, 0. Y-intercept, plug in 0 for all your x's, and you get 0, negative 2.5. So again, we're going to be in the bottom left and the top right quadrant. All right, square root functions. Now, this is the one where you got to be careful. Okay, it's not hard to do, but there is an extra step that a lot of you guys like to forget about. So let's go ahead and graph it. So this has gone left 1 and down 2. It has been reflected over the y-axis. So typically that pattern looks like this, but because we're reflecting over the y, we need to make that change vertically negative. So I'm going to go right 1, down 1. Right 4, down 2, right 9, when down 3 is going to be a little bit off my graph, but we get the general idea here. So now let's go ahead and solve algebraically for our inverse. Now this isn't really the hard part. A lot of you guys are fine doing this. All right, so I'm going to add 2, multiply by a negative 1, we'll go ahead and square both sides. Now, when I square that negative, if you want to leave it there, you can. But when I square it, it's really going to become positive because I have it factored out. So I'm going to go ahead and drop it. What you can also consider, that negative means that graph has been reflected. That negative means that graph's been reflected over the y-axis, reflected over the x-axis. Reflected over the y-axis. And if you think about a parabola, if you reflect it over the y-axis, it's not really changing your graph because it has that axis of symmetry on it. So when I square it in this form, I'm still going to have x plus 2 squared. If you want to leave that reflection over the y on there, you're welcome to. It's not wrong, but it's, again, if you're squaring it, it's going to make it positive. Then last step here is going to be just to subtract 1. And you have your inverse function. Now, the part that all of you guys tend to forget, not all of you guys, but the part that's most frequently forgotten. When we look at the graph, it's a little bit easier to tell. If I were to just go ahead and graph this has a vertex of -2, -1. If I were to graph this parabola, okay, there's something different between your inverse and your original function. Okay, that inverse has a lot more graph to it because remember, we have to include that domain restriction because this is only graphing a certain domain in a certain range. Remember, the range of your original is going to be the domain of your inverse. So we need to consider the range of the original function. So the range of this original function is -∞ to -2. That means the domain of this function is going to be from -∞ to -2. If we want to write that in inequality notation, we would say x is less than or equal to -2. I apologize, those should have been brackets. I don't know why I used a parenthesis. So we'll go ahead and graph that parabola. Okay, left 2, down 1. And again, I'm only graphing that left side because I'm only graphing when x is less than -2. And that's my inverse. Okay, again, you can check by looking at your x and y's and notice that those x and y's have been flipped. All right, so the last thing with inverses is just a way to prove if functions are inverses of each other. One of the things that we could do was use composition. So instead of just solving and saying, look, it is, we can prove it using composition. So what we did was f of g of x, and we did g of f of x. Both of those things should be equal to each other, and specifically, those things should equal x. So let's start with f of g of x. So I'm going to replace x with the g of x function. So that's going to be 5x to the 5th minus 9. So that's the x. And then from here, I just need to simplify. So I do get x for the first one. I still need to do the opposite direction, though. I still need to do g of f of x. So that means I take the g of x function. I'm going to replace x with f of x and simplify from there. So 5th root to the 5th power, that's going to simplify. Those 5s are going to cancel. And I'm left with x. So the fact that f of g of x and g of f of x both equal x, that is your proof. All right, so that is it for inverses. Again, another review. We do have a day of new content coming, so don't be too bored if you're looking for something new to do. Next week, we are going to do some new stuff on the Thursday day. It's going to be a little bit different. But this review stuff is really important because, again, when you look at it, concentrate it in a specific unit, you can just get in that habit of just knowing, well, I've done it for every other question so far. So it's important for us to really be able to see these kind of combined together. But again, to do for today, work those practice problems. You'll submit those for your completion grade. If you need help, you can jump in that Zoom session, send me an email, do a video request. You also have that 7B check that you can do by Friday. If you have questions, feel free to reach out.